Hey everyone, welcome to Interactor tutorial for creating a new interaction type from scratch. So we will be doing this interaction, so it will be brand new interaction type. We got a lot of interaction types built that comes with built-in with Interactor, but I just thought it will be cool to have some magic type interaction without touching the objects and levitate them into air. So as you can see over here, we got a lot of interaction types, and you can use them in many creative ways. But if you want to create your own interaction type, that is also quite easy, and we will deep dive into the codes, and in the end you will have a good understanding of how Interactor works. Okay, let's just open our codes over here, and this will bring us to our main loop. So this update over here, it works for all effectors in every frame, and it got the objects in our range, and it checks their targets with the effectors. Also, we need to open our interactor object, and we will start from here. So when you want to create your own interaction, first you need to create its tag field and interaction type enum. So tag fields are just attributes, so it allows us to put our interaction types in groups and makes them sub-selectable with additional drop-downs. So let's just edit over here. I'm gonna copy the last line, and so this new interaction type will be grouped in Magic, and it will be named as Levitate. So as you can see, they all have some int values, and I just grouped them in 10 intervals. So the manuals start from 20 and they can go up to 30. And I will rename this, I will give a 110 value for the magic. And then, so when I save and go back to the interactor object, as you can see, it is just right over here and it is selectable, but it doesn't do anything right now because these tag fields are just for inspector interface. So let's also add our new interaction type in the actual interaction types. So this will be a Magic Levitate, and it will get the int value from tags levitate. And that is done. So we created our new interaction type over here in the interactor object. So let me just explain how the interactor object works with all the type scriptable objects. So when we start our game in the awake, interactor object just gets all the interaction type fields and makes every one of them null except the one we choose, because we don't need the other scriptable objects, and we are checking them if they are the selected interaction type. If it is, we are assigning them into the active settings. So active setting is actually the one we are using, the one type we are using. Okay, and it is also checking here if is there active setting exist or not. If it is not exist on the object, it just sends a no settings file error. To prevent that happen, we need to assign a scriptable object, a setting file. But over here, when we select the Magic Levitate, we don't have any. So let's just add that one as well in the interactor object variables. Over here, under the cover setting, I will put the newly created Magic. I will rename it as Magic settings, and we also have another attribute over here. These are conditional scriptable objects. So it will just check. So in the essence of things, every one of these fields in Interactor object, they are just not visible. It just shows the one interaction type that we selected. So to make it happen, over here it just checked if the object type is this field, belongs to this field. So let's also add that one as well. Over here we have some conditions. So it is just checking the interaction types int, and it is looking if that type is in its interval. So we just created a new type, magic. Let's name it as magic enabled, and it is starting from 110, as you remember, and it can go to 120. So it depends what you want. And now it is, since we added a new check for that, I can change it with this one, and then it will be okay. So when I select Magic Levitate, it will show me the magic settings. But right now it is just another cover type interaction, because we just add the magic settings as the cover type. We will create its own scriptable object, but right now it is just working fine. And if we select the multiple cockpit, it will show the multiple settings. So this is just for a better interface. We don't need to see other fields, and the other fields get nulled when we start the game on awake. So let's also do that. Over here in the awake settings, it is checking all the interaction type fields and leaves the only one we are using right now. So to do that, let me just copy again the last line. And if the magic enabled, which means we selected the magic type interaction, and the magic setting is not null, then active settings is now magic settings. So right now the object won't disabled when we start the game if we assign over here a setting file, scriptable object. So right now we need to create a new scriptable object for the newly created interaction type, which means our Magic Levitate. So our scriptable objects over here, some of them has nothing. They are just inherited from the interaction type settings. Also the active setting over here is interaction type setting from this. So all the other interaction types actually inherited from the interaction type setting. Let me just show. So this is our interaction type setting, and if I open maybe manual, it has nothing in it, and it is derived from the interaction type setting. Okay, I'm just gonna come over here and duplicate the manual, and its name is manual 1 right now. Let's just double click it to make sure. Okay, just rename it, and I will let it recompile. So okay, now I can change its name, and I will tell it will be a magic. And also I will change the file creation shortcut names. So when I right click in the project menu, I can create a new magic settings over here. So it will also change the file name over here, as you can see, and I can now create a new magic settings. So it is just an empty scriptable object right now. Some of the interaction types has a lot of settings, a lot of properties. Some of them has nothing yet. And maybe they just don't need anything. Okay, so we just created our magic settings and we can assign a new magic setting over here. Actually, let's delete that. I will put it somewhere else. Also, we need to change now we can change the type to magic, because right now we have a magic class derived from interaction type. Also, let's go back to object and let's change this one into magic. Now you can have your own setting file because we created our scriptable object. Okay, everything is set. These are just the boilerplate codes you need to do, and right now it is done. So we created our new interaction type. It is doing nothing, but it works just fine, and it is selectable. Okay, I will put my magic over here with the other ones. And it is assigned. So now, right now, when I press the play, the object won't disappear. It is now magic interaction, but of course it is doing nothing yet. So let's go to Interactor object and start writing our some behaviors for it. To do that, I will just use the shortcut. And in the update, as I told you earlier, all the interaction objects drops over here, and they will be checked by every effector. So if you have 5 effectors, they will get checked 5 times. And depending on the interaction type, they will drop into the case. So let's also create a new case, and this will be interaction types and newly created Magic Levitate. Okay, so this is where all starts. So all the targets of this interactor object gets assigned into all targets, and interactor object itself gets assigned into interactor object. So we will be using this tool a lot over here. So for example, we got 2 targets, left and right hand, and it will be checked 10 times if we have 5 effectors for each target, right? So let's first create a for loop for all the targets we have. Right now we are getting all the targets and we are checking every one of them, and we will tell, hey, if this target, if our current target belongs, its effector type is our current effector's type, is same with the current effector type. If it is not same, which means that target belongs to other effector, so this effector can just continue. It will just skip, because when the food effector tries to check the hand effector, it can't do anything. It needs to pass. It has no business with that. So we are just skipping that by this. And now there is also other main control over here, and we will check if this effector, our current effector, which is like this, our current effector is connected. So the left hand, for example, is connected to anything. If it is not connected, okay, that's great. Let's tell the interactor IK start a new interaction because it is available and it is also same type with this target, so it belongs to it. So it can start its new interaction over here, and that is needed a effector type over here, and also as you can see target and interactor object, which are these targets and the interactor object we are currently checking over here. This is also another for loop for the all interactor objects in our sphere area. Okay, so we just started our interaction. Let's just make a quick test. I will just now put a left hand effector on it. Let me just open my spawner window. Oh, we don't have any file. Okay, that's not a problem. Let's just assign from the save data. This is protoman. Okay. So I'm just gonna open my spawner mode. I don't need any components at pivot and object direction. Let's put a left hand on this one. Okay, so the interactor object right now has one effector target which belongs to left hand. So which means the only left hand will go over here. And it will start the interaction because it is not connected. And it will just start once because, it will just start again and again because we didn't put any controls, as you can see. It is starting to interact again and again. So to prevent that, we can also say, hey, right now if you are not connected and if you are available, okay, just connect. And this connect will wait an array place. This array place also belongs to effector's index over here, which is cached as this. And then let's see, it needs to object and target, which it is, which this effector will connect. So we are also have those information and the interactor object. So right now, let me just quick check why it is angry. Okay, I put them in wrong order. Okay, now we connected the effector and it won't enter this block again because right now it will be connected to this object and to this target. Let's also make another quick test. So it will just connect and then stay like that. And it just ended because over here we didn't select our interaction settings, the interact settings pause. Now it will just pause and wait over here. Okay, also I'm just gonna make the rigid body kinematic. I don't want it to fall yet. Okay, so another check would be, before starting to connect to this object, we need to check if this object in a good position for this effector. So to do that, if effector check, and this effector check needs a target, which we are now processing, and also an index, which is I again, and also the Z only option. So it needs to know if we are going to check the Y angles for this one, for the objects on the ground. So it is also the setting over here, Z only. Okay, let's also give that. It is interactor object Z only. And let me see. Okay, it is looking for the transform actually. And if it is okay, then we can connect. Otherwise, we will wait. Also, we can let the interactor object know it is getting connected. It is available to get used by any effector. So to do that, also we have interactor object and add effector usables. And this one also waits for an effector as int, which will be this. So this will tell the interactor object, hey, left hand can use you right now. So it is it can be a valuable information for other effectors. Maybe you want to use your both hands for same object. So right hand needs to know left hand also can use this object, is in good position. And this also makes the object activate if you are using the global the outline material. It can switch the on state. So let's just add that. And over here, so we will enter this block one time when the effector check gets true. And then there is the other way. So since we are connected now, we can do other stuff. And we can do the same effector check. But this time, if it is not good, if it is out of range and bad angles. Also, since we are now connected to this object, we can use the, instead of the target, we can use connected target. Because right now we are not connected to this object. And also, instead of the interactor object, it can be a connected to. So this is also interactor object. And these are all assigned over here in the connect. And we are checking if it is not good anymore. Okay, you can resume the interaction, which means ending the interactions over here. And the resume interaction just needs the type, because it doesn't need any other information. It will resume the interaction. Also, we can now remove the effector from usables. Interactor objects, remove. And this will also wait for an int, which is same. And now we can test again. Also, one more thing, we need to disconnect this effector right now, because we are ending the interaction. To do that, there is a disconnect. And also disconnect waits for the effector type, the array place, like this. So we are set now. Let's just test it. But before, I'm just gonna assign a outline material. I will just change the shader. I don't need to assign any material over here. Let's find our material. Actually, it is just over here, but it is, since it is default Unity material, default Unity cube, we can't change. I will just select a global, maybe medium. How about large? Okay, large is better. Okay, now since we have our interactor material, it can change the material state depending the object, if this object gets usable state from any effectors. Let's test it. Okay, right now it starts with off state, and now it is in our sphere trigger. Let's also put the scene view so we can see what's going on. As you can see, object enters here. Now it is in the update loop, but the only thing gets checked is this target, and it gets checked by left hand right now. Other effectors do nothing. Let's go closer and make it in the range of our effector rules. And as you can see, the interaction started and we got our use text over here, and the object also gets selected, which means we can interact with the object. We are already interacting with the object because we started our interaction earlier. So this interaction will have two states. The first state will be this one. I will levitate the object. And the second state, the first one is actually start automatically when the object in good position with the given rules. And the second state will start with the player input. So which means pressing F. When I press F right now, it does nothing because we didn't code it yet. So we didn't code yet. And when it goes out of reach in a bad position, the interaction just stops. Okay. So let's go back. We are now just turning the object on and off over here. So we are checking the condition for turning it on, and we are checking the condition to turn it off. But if the conditions are good and we are still connected, there will be another case which we are connected and we are ready to do something. Okay, to do this, we just go to jump into Interactor, the Magic scriptable object, and create some behaviors. For example, right now the main issue with the object is my target actually doesn't get updated, doesn't get rotate towards the player. So if I come over from different angle, my hand will get a weird rotation. So I want to rotate the object. I want it to always rotate to the player. Okay, so to do that, let's create a new method over here. So it needs to be public because we want to access it from Interactor. Set rotation. So this method needs to know two things to rotate the target. One of them is the target's position, and the other one is the effector's position. So it can rotate the target towards the effector, right? So let's just create an input for it. Interactor target, and one for the vector tree. So because we will just give a position, it will be an effector position, and then it will get the target's rotation. Oops. And we will use a quaternion look rotation over here. So quaternion rotation needs up and forward vectors to rotate an object. So the forward direction will come from the target itself. Interactor target transform position minus the effector position. So this will give us the needed direction over here, and the upward direction will be a regular vector tree up, the world up position direction. So we are good right now, and we need to set this. We need to call this method over here. Let's go to Interactor, and so we are connected to object and we are good in position. So we need to update the position from here, right? To do that, let's just use the Interactor object and access its magic settings and call the set rotation function from here. So as we set the inputs, we need a target and we need an effector's position, which is updated in the effector workspace. You don't need to do anything for it, you can just use it. And now it will be updated with this rotation. Let's just test it. Now I can come over here. I'm just gonna increase the range because it is right now, it needs to be too close because it is over here. It thinks because it is prepared for close by interactions, but this will be a distant interaction. So let's go to target and get the interactor values. Now we will override the maximum range over here, and I will make it 2. So our sphere range is 1.8. So when it enters the trigger, it will just get in good position if the angles are true. So when it enters, it will start interacting, and I can interact with it. And as you can see, hand is always rotating towards the effector world position, and it is good. Okay, now we can start the levitation process. So it will also in the magic. Let's create another method and let's call it levitate. So first we need to get the interactor object itself because we will use its rigid body, and interactor object, and then we need the player's position, transform, let's call it player. Okay, so this interactor object has a field for if this object has rigid body or not. So we can check it by has rigid. If this one has rigid body, so we can add some force for it. Also I will, okay, let's just add it in interactor object and rigid add force. And now we need some variables for it. Let's make a public vector tree because add force needs a vector tree. Let's call this one levitate force, and this one will be used in here, and the force mode will be acceleration because I want to move it slowly into air. So okay, it looks good for now. Let's find our field. So we added our first settings over here. Let's put 100. And also, I think we need to activate the rigid body. Let's see if it is okay. Okay, it is not enough right now. Let's increase. No. Okay, sorry. We didn't call anywhere this method. So let's just copy it. Okay, now we will make another condition over here because I want to levitate this object when the interaction on pause. So we can check that one. Interactor IK is paused for this effector type. If it is paused, which means our hand looking towards the object right now. So if it is okay, now we can, where was it? Connected to and magic settings, levitate. Now we can use. This was waiting for the interactor object itself, which is the one we are connected to, and the player transform, which is also cached. Okay, now we can levitate the object. Let's also make another try. Okay, actually we need to turn the rigid body on again. And we are done with the rigid body, we are done with the material. Okay. Now we will use a 250 force. Okay, it is working, but it is too much. Maybe we should try 10. So I want this object to stay stable in air. Okay, it is levitating and the object goes out of range and the interaction just got stopped. Not resume, just stop. So I want this object to stay in position in an organic way. So to do that, let's first create another variable, and this will be a float for the levitation value. So it will have a y value for the where this object will stay, and this will also get calculated with another float. Let's call it distance, and this will get the levitation that we assigned, and also it will get the interactor objects y position. So, and then when we are getting the distance, sorry, when we are adding the force, we will multiply with this one. So the more object goes to this predestinate this location height, the less force it will get this way. Also we can over here interactor object, again rigid velocity, to also multiply this one with the distance. And also we can use a speed value over here, another float, and it can also 1f. Again, let's leave it like this, and let's multiply it with the speed, so we can determine how fast this object can go up. So let's just try, and I will put a height value around 1.6 because this character is already 1.6, 1.7, so it will float around here. These weren't public. 1.6 for the height, and maybe 1.6, maybe 0.5, sorry, 0.5 for the speed. Let's just test it. And the levitation force is still 10 right now, and it will slowly goes up, and as you can see it gets less and less force because it is getting closer and closer to our predestined location. Let's also add more force. Okay, I think that looks good. We can make it 100, I guess. When we leave, it will just drop. Okay, looks okay. Right, maybe we can make this one. Okay, let's leave it like that, but it is going too fast. Let's make it slower. And since we are on the Unity, I just add another target over here. Let's put a right hand. Let me just enable my pivot. my right hand forward. So now we have two different targets. So left target will be checked by left hand, and right hand target will be checked by right hand effector. Let's see what will right hand do. Over here I can pull the object in air, and right hand doesn't seem to do anything right now because we didn't override the range. Let's also make it 2. Okay, over here. Alright, now we can levitate the object with our 2 hands. So sometimes, as you can see over here, hand just goes into the character. You may see them also in the other videos. So that is just because of the rules we give over here. We can make the interaction zone narrower, or for some specific interactions we can give the targets overridden narrow angles to interact with. So that is pretty easy to fix, and right now it is this interaction type getting shape, and we have a little more to do. So over here, so I want this object to go with the player when it is getting aired. Let's do that one. To do that, I think we need two private vectors. Private vector 3. This one will be a position, and private vector 3. This will be a position offset. So to position offset, we'll get the current difference with the interactor object and the player. So it needs to maintain that distance and rotation relative to player. So the object will seem to stay in place when the player moves. And also the position will be interactor object's own position update. So we will use that. Okay, let's make our calculations. So the position will get the player position, but first we need to calculate the position offset, right? And the position offset needs to be assigned one time only when the interaction starts. So let's also create a private method and call it grab, and on the grab let's assign the offset. So this grab needs to interactor object and player position, like this one, and it will get the player position from here. Let's just put this as input, but this can be a vector 3, so let's call it player position. And then player offset will be interactor object's position minus the player position. So this will give us the difference between two objects. And then we can have a lock over here. Let's create a bool. I will make it public to see what's happening. Levitate. So if we are not levitated, grab the object, and this will get the interactor object and player position. Okay, this is already transformed. And then the position, right now we just assigned our position offset. also we need to set the levitated true. So we are entering the method levitated off in the first frame of interaction, and we are grabbing object, caching the position difference, and then we are turning the levitated true, and then we will skip on the next frames. So the position will get position offset plus player's position, and then we will update the position's y value, because we don't want to modify the y value since we are adding force for it, and it will get the interactor object's current y value, and then interactor object will get updated with this new position, the position. Alright, so right now this will enable us to take the object with us when the interaction starts, I hope. Well, let's test it. Okay, we are levitating the object, and object starts to go with us. We can interact with two hands. Alright. But as you can see, once we deactivated the object, the position offset will get the old position, because these scriptable objects will record the values in the runtime and hold that. So we need to reset the object. To do that, first of all, I will create a private void on disable, and also I will call a private void release. So when we release the object, levitated will be false, and also the position offset will be resetted by vector 3.0. So when we disable the object or destroy the object or end the scene or leave the object ground, it needs to be resetted. And also we need to call this release from some other public method called reset. Okay, also I will use it for something else. So let's just add the release over here, and then let's call the reset when we are done with the interaction, which means over here, if the interactor object goes out of range and when we are ending the interaction, we will just also reset the interaction over here. So this needs to be interactor object dot the magic settings reset. Okay, I did the reset before the disconnect, because after disconnect, this connected to will be null. Okay, also let's just save this one. I think this is okay. Let's test it. Okay, now I'm levitating the object. It goes to right hand. I'm leaving the object, and when I come from with left hand, it up, and with the right hand, okay, it is working just fine right now. So we are resetting the object, we are taking it from some other place, and it is working fine. Alright, now I want to pull this object with a player input. So far we just managed to interact with the object in an automatic way, which is handled in the update. So to use the player inputs, we got another spot in the interactor called start stop interaction this. So this will be called by interactor, and that will be called from some other place, maybe your input class, your UI class, and so you can start and stop interactions with player inputs. So this one has interactor objects and selected UI position, but you don't need to worry about that for now, right now. And over here, when we call this one, when the press input button, use button, and it will get checked over here. It has two different spots. One is for the connected ones right now, and the other one is not connected ones. For example, the manual buttons starts with input without any connection, so you can connect after your input. But in our case, we already connected the object, so we will put our code into the connected spot over here. So let's just create a new case over here. If this interaction type is magic and so we will use the interaction over here. And then first of all, we need a focused object interaction type. Since we are connected to object, it needs to know, hey, what kind of interaction type you are connected to, so I can assign the interaction according to that. To do that, when we connect to object, we can just assign the focused interaction type. Hey, this is interaction type magic. So you can use inputs according to that. Okay, now we got our magic, and it will go right over here when we press a button. So the first check we need to do, hey, if this effector is the connected effector. So let's check that one with effectors. This connected to our start stop object. If we are not connected, which means this effector has nothing to do with that, so just return. So right now over here only the left and the right hand will enter. Okay, and also since we are entering here twice, but I want to use my input only one time, so we have another check over here in the interactor, check once per object, and if it is not checked before, it can return. So sorry, if it is checked before, if it is used before, we can return. It is just a bool. So if not, we will just make it true and continue. Okay. So right now over here there will be only one effector which enters first, and so we can add some behaviors for it. But first we need to create some methods to call. So I want it to pull the object in front of the player. So let's also create another bool for that, public bool pulled, and then later I will use another one, bool pushed. For the pulled section over here, let's use a public method void pull, and this will just make the pulled true. And then also we can make a quick check over here. if pulled before, do nothing. Okay, so we can now call the pull from Interactor's input. As I said before, we will only enter here once, and when the player press F button, use button, or depending on your choose. Okay, let's just call this one start stop object and magic settings pull. Okay, sorry about the typos because it is quite late and I'm working since the morning. Okay, now we are pulling and we can put some conditions over here. So if we are pulled, we can do something, and if we are not pulled, we can push the object with player. So we are switching the behavior over here. So we will tell I think I need another vector tree, a temporal one, and let's call it a relative position. And it will get the player's position plus it will get the relative rotation for it. It will be player's rotation. Now we need some values right now. Let's create a vector tree. It will be a pull position, and then it will multiply that one with this player rotation. So the object will always stay on the same spot relative to player. And okay, then again the similar to this one, if player has rigid, if the interactor object has rigid body, and then we can add a force for it, for the pulling object. And this force, I think we need to calculate something else because we don't want to add a lot of force. Let's call another vector tree for the force. Let's call it distance pull. It will be the relative position minus interactor object's position. The difference between these two locations. Okay, so we can put it over here. So also we can create a new float for the pull speed, pull force. Let's call this one pull force. Also let's multiply that one with it. Okay, it can be acceleration, that's good. I think we are good to try. And did we just call this one? Yeah, we already called this one. So let's just go back. Now let's fill the new fields that we added. These are going to be pull position. So I want my object to stay around 1 unit up, and maybe a bit, actually not, of course it needs to be forward, because right now on 0, X and Z it will be the player's position. So let's give it 0.8. So it will be 0.8 in front of the player. And the pull force, I don't know, let's start small. So when I press F, so I am levitating the object right now, and when I press F, okay, it is coming slowly. Okay, that's too slow, maybe 200. Okay, it sticks with us. Let's try again. 200 looks good. So I'm pulling the object. Okay, hang on. All right, the thing we are having, the issue we are having right now, just doesn't reset the levitated and pulled, and it starts with these bools with true. Let's also reset those. When we finish the game, levitated gets false, pulled gets false. Okay, let's go back. Okay, let's try again. Now I'm going over here, pulling the object, and it goes with the object. And alright, that is looking quite magical. The player may look like a wizard right now. Now the thing we need to do, lastly, the pushing the object, and which means pressing the F again, getting the second input to end the interaction with the climax. Okay, so right now I can hold the object over here with my right hand. I am switching the hands and pulling the object. Okay, so far so good. So let's do that. Now I need a push public method. Let's create it. So this will also need an interactor object and player transform. And actually it will be similar if we are not pulled yet. Just return, because we need to pull first. And then we need some calculations over here with vector trees. Again, a relative position would be the player's position plus again a player. Actually, this will be a bit different than the pulling object. Right now I need a vector from player to object, but it needs to be in a forward direction. So this needs to be a player right multiplied by again pull position dot x plus player up multiplied by pull position y, but not z, not z. We just need the, because if we include the z, it will be just object position. So let's also calculate the vector 3 distance push. It will be an interactor transform position minus this new relative position. And then if the interactor object has rigid, then let's add another force for pushing the object, and it will be a distant push, and we need also a push force. And this one should be impulse, so because it needs to be a climatic, it needs to be a climax. So also we can set the pushed through right now, because we are actually pushing the object. Okay, let's call this one again in the interactor. So we need a condition over here. If this object is already pulled, right? If this is connected to actually start stop, magic settings, pulled before, so it is time to push. Otherwise, just pull first. And I think that is okay right now. And the push needs a interactor object itself and the player's transform. And now we can push. Let's just try. And for the push force, let's give it maybe 10, because this one will be impulse, so it needs to be lower. Okay, let's test it. Now I am levitating the object and it goes with us. I am pulling it and then I am pushing the object. I am doing my best, but it sticks with us. Okay, something is wrong over here. Let me just quickly check. So we are pushing the object, but we are not resetting anything, I guess. So let's just release the object, because we don't want to levitate anymore. Yeah, let's release the object now. Okay, you can go now. Let's test again. Now I am levitating the object, pulling, and I am pushing it over here. Okay. Is it too low? No. Okay, we are missing something over here. So when we pull, okay. So if we are pushed, okay, pushed, don't levitate anymore. That must be the issue over here. Because we are trying to push and at the same time we are trying to levitate it again. And let's lower the push force back to 10. Now I am okay. Also, this pushed guy needs to reset too. Let's try this one first. I'm pushing it and okay, that works just fine. Now let's add this push to our reset. False. So I just separated these two methods because when I release, I switch pushed to true, and I don't want to push to make false again until I press the F use button again. So that is why I separated them into two different methods. So let's try again. I think our new interaction is completed. So it is not perfect. It needs to be tested a lot more. And also let me just lower these angles because they are too much. The left hand could be, let me just see them in player. Okay, we can use not the offset, we can use 110. Actually, let's make it 100 and let's make it 0. And the other one, the right hand, can be like that. Again 100, but this time it should be 80. Okay, I think they are similar right now. Yep. Okay, let's test again. Now I am pulling the object with my left hand and switching back to right hand, and I can leave it and then levitating again, getting right hand, but this time I'm pulling object in front of me, and now I can more precisely control it, and now I'm ready to send my magic spell over here. Okay, I think we are done, and then we can take it back, right, again, because it is resetted and it is just working fine. With some VFX, it can look really cool, I guess, for a magic for a RPG type game, maybe action RPG. Oh, okay, as you can see, there are some bugs. But that is not important. So this was an example how to create a new interaction type, how to use Interactor's abilities and its effectors, and the other codes over here just regular behavior codes. So you need to do this for any kind of interaction in Unity games, and then the rest of them, all the procedural animations, all the I-key calculations, and all the organization of interactions and their relative relations with other interactions, and all necessary informations will be given by Interactor. And there are some boilerplate codes for the creating Interactor type over here. So you need to create your interaction types, and then that's all. You are good to go. When you need the thing, one more thing I want to talk about. So right now we are just using the magic settings. So if we put a lot of cubes, they will also use the same values, and that is a problem. So to prevent that happening, you can come over here in the awake function. As you can remember, we are assigning the magic settings to active settings over here, but you need to instantiate this scriptable object and use that one for this object and for each object. So this way every Interactor object will be having its own magic settings, so they won't affect the others. And to do that, there are also examples for that. It is already used in pickables and push. And to do that, let's just create here, and it will be, hey, this magic, you are using the magic? Okay, then you need a new magic for that. What are we doing? Instantiate a new magic and then use that one. So this way it will get a new magic, and the changes in runtime won't be saved because the instantiated magic settings will be destroyed in game. So that is also another thing you need to remember. Okay, nice bug. And let's push this object. Let's select this object to another value. As you can see, it is just resetted because that object just destroyed. And also one more thing before closing the video, I will just show a quick thing. If you want to look to your targets, it is also quite easy on the Interactor again. And let's go to the update, and when we start with the interaction, we can start a new look over here on the Interactor, new look order, and the look order will need an interaction object. In this case, it will be Interactor object, and also a look type. So we can use on pause over here, and when ending the interaction, we can define another look order, and this will be an after. So with these two lines of code, the player will also look at object when interacting with it. So also let's make one more last try, I hope. Hang on, let's just first enable our look settings. Let's make it always, so it will be on pause and after. So we are going to object, and it starts to look and ends then, and then it will be more alive, like this one. Okay, so that is all for this tutorial video. I hope I managed to explain things well. It is a bit late and I am still working since the morning. Sorry about the typos and all the wrong speaking. I'm excited to see your own interactions. If you create your own interactions for Interactor, just let me show them, send some videos maybe, and I gladly watch them, and I will most definitely enjoy them. And that will be all. Thank you for watching. See you on the next one.